there are a couple things I wanted to go over just to kind of review stuff we did last semester. So today we're going to do some easy review. Tomorrow's going to be a little bit more of a challenge, just so if we remember things. Today we're going to talk about valence electrons. So the first thing I want to do is I want to look at our periodic table. So if you guys want to open yours up, I'm going to open mine up. And we're going to look at our periodic table. And I really just want to get back to remembering a couple things about our wonderful periodic table. So let's go through and remember things that we can identify from the periodic table. What information can we identify from the periodic table? Who remembers anything?
I forgot. Oh, wait. I think. Nope.
No, you got this. What were you going to say?
Hold up. Let me look at my notes.
Okay, that's fine. Anybody else got anything they can remember?
Different groups of metals and gases.
Metals and gases, perfect. So we have our metalloid line, which is right here. I'll do that in red. We have our metalloid line, which is right here. Which is our staircase almost. And if we remember, everything on which side of our staircase is going to be our metals and which side of our staircase is going to be our non-metals. You remember which side the metals are on?
The left side.
The left side. So left is going to be our metals, which means the right side is what?
The gases.
The gases, we're going to use our non-metals since not all of them are gases. But that last column is our noble gases, correct. What else do we remember? Felix, you find what you were looking for?
Yeah. What's it called? The most reactive metal is francium or whatever, and then. Oh wait, no. Yeah, that is. Never mind. And the most reactive non-metal is. Wait. This thing doesn't let me zoom out. The most reactive non-metal is fluorine.
Perfect. All right. All right. So we know our most reactive metal. We know our most reactive non-metal. I did get something in the chat that we can figure out our protons, neutrons, and electrons. Can anybody tell me how we find the protons? Or let's go specifically, let's look at beryllium. How many protons does beryllium have?
4.
Oh, 4.
4, perfect. And so where'd you guys get 4 from?
Top left.
Top left, this number right here, that's our atomic number. And so our atomic number tells us the number of protons. Do you guys remember? Let's skip neutrons because that one's probably the most difficult. Let's go with electrons. How do we figure out the electrons? And let's say our atom is neutral. What were you saying?
Isn't it the same thing?
It's the same as our protons. Perfect. In a neutral atom, it's the same as protons. And then what about our neutrons? That one's probably the hardest one to figure out just because there is some math involved. Do you guys remember what math?
You divide the
Don't you
mass
do?
number and atomic number?
Yeah.
Mass. Perfect. The mass number minus the atomic number. And our mass number, let's look at beryllium again. What is our mass number for that one?
9.
The 9. Perfect. Right here. Do you have any questions about any of those things so far? We remember all that? Is it coming back to us a little bit?
Yes.
Sweet. All right, there's one more thing we really need to remember about our periodic table. And that's going to be our wonderful valence electrons. The most important things to us most of the time because they tell us reactivity. They help us with making our Lewis dot structures. They help us with coming up with bonds and telling us how many we need. So do you guys remember how we determine the number of valence electrons?
There's a number on each group.
The number on each group. Perfect. So we're going to start over here with 1. The next column or the next group is going to be 2. Is this one 3? All right. You said no. Which one is 3 then?
Helium?
Not helium, not all the way over here. This one's not 3, but it is that direction.
Boron?
Boron. So we're going to go to here. So this is 3, which means carbon is what carbon's group is how many?
4.
4. And we're just going to keep going. 5, 6, 7, and 8 over here. There's one exception to that last column. Which one has the exception? Do you guys remember which one the exception was? It's going to be helium. Do you guys remember why helium was the exception? What was special about helium? If you don't remember, can you take a guess as to why it's not 8 or how many it's going to be?
It's valence electrons.
How many?
It has 8 of them. Or no,
It does not have 8. So how many does it
it's
have?
not. 4.
Not 4. We're getting warmer.
2.
2. Perfect. It has 2 valence electrons. And it has 2 valence electrons because helium, when it fills its outer shell, it goes 1, 2, and it's done. It doesn't need any more. So it's done after 2, while the rest of them, they need to fill these 2 columns and these 6 columns in order to have their full outer shell. Wrong button. One more thing I do want to label, just so we remember what it is this middle section right here. This section is super important to us because it's called our what? Do you guys remember what this section is called? Starts with a T.
Transition metals?
Transition metals. Perfect. Transition metals. And so those ones are super important because we can't figure out the valence electrons solely based on what the where these ones are on our periodic table. So we have to use our ion chart. And so that ion chart is actually going to be super important to us later on in this unit, because we're going to actually talk about those negative ions, which are sometimes called polyatomic ions. And we're going to get into that a little bit more later. We don't have to worry about that this week. It's going to be next week's stuff that when we start that. I just wanted to give you that heads up that that ion chart is coming back. So we are going to use that one later on this semester, and we're going to use that one quite a bit, actually. Does anybody have any questions about anything we've gone over on this periodic table that we reviewed upon just a little bit, just to see how we were doing with everything? All righty then. So there's going to be two other things we're doing today. The first thing is going to be this valence electron review. So if you guys open up on Canvas, it's going to look like this. It's 2 pages. It actually isn't too bad. I think you guys can do this one pretty quickly, especially this first page, especially since we did a lot of this as a group and you just have to look at your periodic table again. So for this first one, what we're doing is we are identifying the valence electrons. So it says up at the top, it says that valence electrons are the electrons in the outermost principal energy level. So what that means is if we thought about the electron configuration, which is something we did last semester. So if you remember that, that's going to be beneficial. We had those S groups and we had those P groups. In our outermost valence electrons, or our electrons in the outermost orbital, or outermost energy levels, are the ones in the S and the P groups. So if we look at this one, this is a different way of looking at it besides just looking at the periodic table. If we look here, this one has 2 and it has 2, which gives our carbon a total of 4 valence electrons. We can also look at our periodic table and we can find carbon, which is right here, and look to see that it has 4 valence electrons. Both are perfectly acceptable ways of finding the valence electrons. Whichever one makes sense to you, let's stick with that one. Let's not make things complicated. Remembering that those are the ones that make elements reactive, and they become reactive when? Do you guys remember why the elements are more or less reactive? What are they trying to get to?
Nucleus.
They're trying to get towards the nucleus. Okay, I like that because we want our electrons, because they're those negative charges, to get close to the nucleus with those positive charges. That's awesome. And so when we have how many valence electrons, are they going to be the most reactive? You told me which ones were the most reactive elements on the periodic table. So let's look. So we're all trying to get to 8. Perfect. We're trying to get to 8. So they are more reactive the closer they are to 8. So if we're looking here, the closer they get to 8, the more reactive they're going to be. So the ones that are in this column, so when they have 7, they're going to be super reactive because they have 7 valence electrons. They're 1 away from having 8. They're 1 away from being happy and stable. These guys over here have 1 valence electron in their outermost shell. They have another shell that has a full valence shell, and they have 1 that's around that full shell. So if they get rid of that 1 electron, their outermost shell goes away and they have a full shell now. So they're also super close to 8. They're 1 away from being at 8 because they're going backwards here. They're going back to the row beforehand, and they'll make it to that noble gas or that 8 valence electrons. So our groups 1 and 17 are going to be the most reactive elements. So just remember that they all want to have 8 valence electrons. The closer they are the more reactive they are. And do you guys remember the name when they have 8 valence electrons? Do you guys remember what that's called? Or the rule that they all want 8 valence electrons?
The octet rule?
The octet rule. Perfect. So that's called their octet rule if we don't remember that. Octa meaning 8. So octet telling us we want a full shell of 8 valence electrons to be stable, to be happy. So let's look at a couple of these. We're not going to do all of them together because you guys are awesome and you guys can do these. So determine the number of valence electrons. So let's just do like the first 3 together. So let's look at fluorine. Does anybody on the periodic table know where fluorine is? Tell me the atomic number.
19.
9. What is it?
17.
Not chlorine, fluorine.
Oh,
9.
9. Perfect. It also has the same valence electrons as chlorine, but how many valence electrons does it have?
7.
7. Perfect. So we're going to go over here and we're just going to put our 7 next to fluorine. Let's do phosphorus. Phosphorus is what atomic number on our periodic table?
15.
15. How many valence electrons does phosphorus have?
5.
Awesome, awesome, awesome. 5. And then one more, we have calcium. Calcium is what atomic number?
20.
20. And how many valence electrons does calcium have?
2.
2. Wonderful. All right. I'm going to leave the rest of them for you guys, but I do want to go down to the next section real quick before I let you guys go ahead and work on your own. So we're talking about Lewis dot structures, just something else I want to refresh you guys on just because I don't want you guys to forget anything. So the Lewis dot diagrams or the Lewis dot structures are ways we indicate the number of valence electrons that are around our atom. We also have ions, which is when atoms gain or lose valence electrons, resulting in a positive or negative charge. And those ions are always trying to get to what number of valence electrons?
8.
We always want to get to 8. We always want to get to 8 valence electrons. So we're going to draw our Lewis dot structures and we're going to draw those ions for both the atom and the ion. So calcium, you guys just told me how many valence electrons calcium had. So can you remind me?
Two.
It had 2 valence electrons. So to draw our Lewis dot structures, our Lewis dot diagrams, we put our element symbol, and then we have to put our 2 valence electrons. Remember, we put 1 on each side, and then we pair them up. So we're going to go clockwise. So 1, 2 valence electrons here. That's our Lewis dot diagram for the atom, but it also wants us to have it for the ion. So now we have to figure out the easiest way to get to 8. Is it going to be easier to try and steal 7 electrons from other people or to try and give away 2 electrons from other people? What do we think?
Lose 2.
easier to give.
Lose 2. Give away 2. Perfect. So to turn it into an ion, our calcium has to lose those 2 valence electrons, which gives it a charge. Is that charge going to be a positive or a negative 2?
Negative.
All right, I got both answers here. So I got a positive in the chat and I got a negative. So let's figure that out. Do you guys remember the charge of an electron in general?
It's a negative.
Electrons are negative. And so when we have calcium normally has 20 protons and 20 electrons. That means it has 20 positive charges and 20 negative charges. and now it just lost 2 negative charges. So now it has 20 positive charges and 18 negative charges. So it's going to be a +2 or a -2 here.
Positive.
+2. There we go. All right.